Hi guys, this is the third and last part of lesson 1, electrons and energy levels. In 1916, this American chemist, the name Gilbert Lewis, made a model, an easy model, called the electron dot diagram. It shows the electrons found on the last energy level, so they're called valence electrons, around the element's chemical symbol, like this. This is phosphorus. It is showing the electrons found on the last energy level around the symbol. I'll tell you how to do it. The steps for writing a dot diagram. First of all, you should identify the element's group number on the periodic table, if it's given to you. So, for example, beryllium, it's in group 2. Carbon is found in group 14. Nitrogen 15, and neon in group 18. Step 2. Identify the number of valence electrons. So we did it before in the video of part 2. So how many electrons are found on the last energy level? I taught you how to find it by looking only at the group number. So for beryllium, 2 electrons are found on the last energy level of that atom. In carbon, 4 electrons. Nitrogen, 5 found on the last energy level, and neon, 8. Step 3. Draw the electron dot diagram. How? Place the symbol first. So for beryllium, you put Be, and then you should put the dots at a time. Each dot represents an electron. So place one dot at a time on each side of the symbol. So starting by top, right, bottom, and then left. And then pair up the dots until all are used. So look at neon. You know that it has 8 electrons on the last energy level. So I'm going to go back, use my pen. So it has 8 electrons on the last energy level. So you start by top, right, bottom, left. You fill the first 4 first, and then the next 4. But they should be put next to the others, to the first electrons that you've put. You should pair up the dots until they are all used. Step 3, the 4. Determine if the atom is chemically stable. Now, how can I determine if it's stable, if the atom is stable? It is stable if all the dots on the electron dot diagram are paired. Now look at beryllium. It doesn't have any paired electrons. So it has only those loose electrons. So it's not stable. It's called chemically unstable. What about carbon? Carbon as well. Look at nitrogen. Nitrogen has 2 electrons next to one another. 1 pair. But look at the other 3. So as well, it is unstable. Now look at neon. All its electrons are pairs. So it is stable. It doesn't have any loose electron. Look at now last step. Step 5. Determine how many bonds this atom can form. Now how should I know? Count the dots that are unpaired. Again, let's look at beryllium. The electrons that are unpaired are 2. So it can form 2 bonds. For carbon, 4 electrons are unpaired. So 4 bonds. Nitrogen has 3 electrons that are unpaired. So 3 bonds. Neon. Any electrons unpaired? All of them are pairs. So 0 bonds. Let's just do an example. I'll choose sodium. Sodium's atomic number is 11. So the first energy level can take up to 2 electrons. And then the second 8 electrons. How many do you still have to put? Don't forget, sodium's atomic number is 11. So 11 protons, therefore 11 electrons. So you still have one more to put. How should I put it? Don't forget, top, right, bottom, left. So top, this is the only electron found on the last energy level. It's called a valence electron. I'll choose oxygen here. By knowing the group number, you would know how many electrons you can find in an oxygen atom, the last energy level of an oxygen atom. So let's see. This is oxygen. Atomic number 8. So first energy level can take up to 2, and second energy level is 6 to get 8. So same thing here. Look at the ones digit, 6. So let's do it. Electron dot diagram. Don't forget, just put the dots, starting with the top. You need to look at this number. The last energy level is taking 6 for oxygen. So top, right, bottom, left. Now there are 4. I need to put 6. Where? Pairs. 1, 2, let's count them. 1, 2, 3, 4, 5, 6. So those are the electrons found on the last energy level of an oxygen atom. 6 valence electrons. Let's continue. Now, atoms with 8 valence electrons are chemically stable, just like neon and argon in this case. And they do not easily react with other atoms. They're stable. They don't need to bond. Now look at the other 7 groups here. Atoms that have between 1 and 7 valence electrons are reactive, so they're unstable. They can easily bond with other atoms. What for? To be stable, to form a chemically stable compound. The elements in group 18 are called noble gases. The noble gases, they don't bond with other elements. With the exception of helium, because it has 2 electrons only, so it just fills the first energy level. It doesn't need other energy levels. So noble gases have 8 valence electrons and are chemically stable. Atoms gain, lose, or share valence electrons. This is why we're insisting on knowing how to find the valence electrons, because later on you'll understand, you will get how to bond atoms together. You need to know the number of electrons on the last energy level. So why? Because atoms gain, lose, and share valence electrons. Why? To become chemically stable. Neon in this case is stable. Okay. Helium as well. Neon filled its energy level, 8. Helium. But look at nitrogen. Nitrogen has 7 electrons, 2 inner electrons and 5 valence electrons. Its dot diagram has 1 pair of dots, but it has 3 unpaired dots. So nitrogen can form 3 bonds. That was it. I will just read a little summary of the whole lesson, and then a little quiz, and then I'll give you the homework. So, summary. Electrons are less strongly attracted to a nucleus the farther they are from it, similar to the way a magnet attracts a paperclip. Electrons in atoms are in energy levels around the nucleus. Valence electrons are involved in chemical bonding. All noble gases except helium have 4 pairs of dots in their electron dot diagrams. Noble gases are chemically stable. Little quiz, kind of a review. Where on the periodic table are nonmetals located? The left side, the right side, the middle, or all of the above? It's the right side. Go on. Which term refers to areas of space in which electrons move around the nucleus? Electron diagram, periodic table, neutron, or energy levels? It's D. Energy levels. All of the elements in group 18 are called what? Metalloids, valence electrons, noble gases, or metals? Group 18. C. Noble gases. Thank you guys. You have a homework, page 273, numbers 1 to 10 for Friday. And I want you to check the link on lesson. I've put all the details there. Thank you so much. Take care.